Okay, apparently we're back. Apologies for that. That was pretty strange. My router just decided to die and I had to restart it. Bizarre. Thank you very much, Spectrum. Anyway, we were dropping too much truth. At any rate, so we were talking about living off Defender. And I would not say that this is legitimately living off Defender because they're bringing their own DLLs, right? They're actually packaging npcmd run.exe with their payload. It's just that the payload is going to look legitimate because it's a Microsoft signed binary, and defenders are going to have to look for bizarre pathing to make sure that it's a legitimate file. All right, next story. Okay, so we know, and this is going to dive right into what we're talking about today. We know that the end of VBA macros is coming, and so do the bad guys. And so in order to change up their behavior, they have pivoted largely from using VBA macros. Not everybody, but a lot of malicious actors have pivoted from using VBA macros inside of Office documents as initial access points to malware stored in .iso files, right? Disk image files. Maybe they're zipped, maybe they're not. But importantly, the reason why this is so effective is because the files inside of those .iso images are not going to contain what's known as the mark of the web, right? The alternate data stream that Windows puts on files to indicate that they've been downloaded from the internet. If you wrap a file inside of an ISO, you put it on a disk image, it's not going to have that mark of the web. Is the YouTube stream working? I don't know. It's a good question. Let me check. It may not be. It may come back. Sometimes it takes a second. Yeah, there we go. Yeah, it looks like we're back up. So, thanks, Dark. Yeah, I do not know what happened there. But at any rate, so we're moving from macros to ISO files, and that's largely what we're going to be talking about today. What's inside of the macro is kind of all over the place, but we're going to take a look at a specific sample today. But I also want to show you, we're going to switch over from the talking head view here to the live desktop. And hey, Clamp Security. Yo, Clamp Security. I love those emotes. Those are so good. I wanted to show you this graph just in terms of trends that we're looking at for Office macros. If we take a look at this graph from Proofpoint, and Proofpoint is in a position to know, right? Because they're tracking everything coming in from email. Look at what's going on with this graph here. You're seeing that from October 21 to June 2022, the use of macros has decreased. It's not like, if careful on the y-axis, right? So number of campaigns, they're saying that, it was peaking at around, looks like 135 maybe, and then dipping to a minimum of 50 in February 2022, which was about when Microsoft first announced that macros were going away. They came back up as that kind of waffled, and then coming back down again. But during this entire time, seeing the writing on the wall, we can presume the use of container files to deliver malware continued to increase, and it doesn't show any signs of abating. So this is kind of and this is, that's container files, and this is LNK files over time, right? So we can see that that's really increasing. Now, the use of LNK files, it's the way that different folks use them can differ, right? LNKs are shortcut files that they're going to appear as one thing, but in fact do something else. And there are some cool ways to analyze LNK files. We'll get into that in a minute. But there are a few things that we'll talk about in terms of detection, of course, and also in terms of prevention, because there are some things that you can do depending on your organization. I'll actually talk about the prevention one right up front because it's one that I think is very important. This is not a cybersecurity awareness problem, I would argue. That being said, cybersecurity awareness can help. So, put another way, if you as a defender are letting these ISO files through your defenses to the point where a user can download them onto a system and run them, mount them, run whatever's on them, you screwed up, not them. That being said, it can be tough to deploy these defenses. So, if you want to make this a little bit easier on you, I do think that this is something fairly new. We've been training users to be wary of macros for years and years and years now. How much have we really talked about ISO files? Do users know what to expect or what not to expect when it comes to downloading files? And what is the default behavior of Windows when downloading ISO files? In some cases, it's to automatically mount it and open it. That's no good. Sometimes it'll warn about mark of the web, maybe not. And if it's zipped, then it won't. So there are a few things that we can do to educate users. That is not the solution, but it is a brick in the wall. And I think it's an important one to inform users that this is something that they have to be aware of now. Things that are different from what we're used to with the macro focused. Think about how much energy we've spent talking about macros and like being aware of Office documents, right? But if this is now the shift in where things are going, we have to change our conversation. Sin, good to see you. Goomba, good to see you. All right. So I have for you an actual factual sample of malware that I have collected this week. And we're going to take a look at that. Let's get some music going. And the reason I wouldn't always feel comfortable doing this, right? But it's not some deal hijacking. It's actually not. I'm not going to claim that this is the most exciting malware ever. And I don't want it to be. I want to show you some run-of-the-mill stuff. This is like the common denominator malware that your users are facing every day and that you have to detect, prevent, and remediate fairly frequently. Now, I can tell you, I want to be careful, right? OPSEC stuff, right? I don't want to give anything away about sort of internal operations in my organization, but I can tell you, I think reasonably safely, this was not something that came in through an email gateway, right? This was something that was the result of some bad browsing choices on the part of a user. And so it's not like it was a targeted attack, but nevertheless, I will say that over the last week, not just my organization, but others in the same ISAC, and in fact, globally, as I spoke to our threat intelligence providers about it, have seen a massive increase in the use of ISO files to deliver malware. So this is happening. It's happening right now. We're watching this change happen in real time. And so I wanted to jump on and use this sample as kind of a case study so that we can understand what's going on, what you might see, and how to deal with it. So that's the plan. So what do we have set up here? Luckily, Starbase is pretty much like ready for work for this. So I've got Terraform that has set up a Flare VM instance for me, and it's ready to rock with everything that it needs. I also have kind of a sacrificial lamb Windows machine here, and that's going to be where we dynamically run the malware, and then we'll blow it away. Right now, this one does have internet access because I want to see those network connections take place. We're going to kind of black hole it from everything else, but we're going to make sure that it does have access to the network, and that's because, or at least to the internet, because I want to see it do its thing. And then we'll just blow it away, right? I'll also say that in terms of best practices, because this thing was like, it didn't have any PII, it didn't have any PHI, which is something that I have to be concerned about a lot. And because it didn't have any identifying information about my organization, I felt comfortable tossing this at hatching triage. And so there are a few things that it found, although honestly not a whole lot. It was pretty disappointing. I found more with my own analysis than triage did in this particular case. And that might just be because of the way that I submitted it or the way that it's running or whatever. I did notice, however, that it didn't run at all on Windows 11. It only ran on Windows 10. So that's kind of interesting. Let me move this over and close like a bunch of these. Yeah, cool. Okay. So let's crack this thing open and see what we're looking at. Let's dive right in. Let me get over to the Flare machine. I gotta reconnect. Let's get back to our Flare machine here. Excellent. Okay. So this is the exact kind of machine that Husky would have you build during Practical Malware Analysis and Triage, the PMAT course. And it is connected to the isolation lab. And we're not going to do anything dynamically with this right now. We're just going to pop open the file and see what we have to do with it. I'm going to pop this into downloads just because I don't like working from the desktop. That's just a me thing. And then I'm going to use 7-zip to extract the zip file. 7-zip, extract here. Okay, it's got a password. It's not, the password isn't infected, but it's fine. Okay, now, I get a whole bunch of metadata junk, and we don't need to worry about that stuff, but I do want the actual file. Your file is ready to download .iso. It's handily underscored, so it's defanged, but I actually want it to mount, because we need stuff off of it. So again, we're taking a look at this kind of cold here. So we're going to open up, your file is ready to download .iso. And let me change the view here to take a look at what we have. We have an app.zip, which is going to get really interesting. We have this icon.ico, and we have this install, which is what? It's an LNK, right? And you can see that it's targeting resources.bat. What is resources.bat? Well, that's right here. So we're going to open that with VS Code. And one of the reasons I liked this sample for education purposes is that it was not obfuscated whatsoever. It doesn't seem to care, at least about this stage. It seems like it cares more about obfuscation in later stages, as you'll see. All right, let's zoom in on that. Enhance. Okay. So, some interesting things going on. We're using tar, which I honestly didn't even know was an alias in command.exe, but it is, for app.zip. And of course, we're putting it where else but app data, right? We're going to put it in app data. And then this is like old school stuff. This is stuff that you would see in any threat hunting course, any incident handling or DFIR course about persistence. So they're going to remove this specific registry key. And I wonder if somebody in chat can explain what this registry key is doing. And then they re-add it, of course. They add a value to that key. A string of app data to healthy.exe with some command line options. Right, it's persistent. So essentially what this means is startup. Right, so anything on login is run. And the reason it's login killer, not boot up, is because it's in the HKCU, the current user hive. So there has to be a current user in order for that registry to apply to anything. Right, so if it were like the machine startup, that would be HKey system or computer. Yep, so It's not removing anything that runs on startup first. I want to be super clear. What it's doing is a little bit of hygiene. It's saying if anything else has the healthy key, it's going to blow that away first, right? It's looking for the value of healthy in there, and then it's going to add it. Does this thing have regexp on it? No, that's fine. We'll just use regedit. So if we take a look at that registry key, we'll go hkcu. Software, yeah. Microsoft, Windows, current version, and then run. You'll see that there are a few different keys and values here. There's a default, which is nothing, and then there's this Microsoft Edge, which has a value of Edge, no startup window, Windows to start, blah, blah, blah. Okay, so Edge, like, starts when we log in. It just does. Okay. But anything else we put in here will also start. So that's really what's going on. They're just adding something. Thank you. HKLM, that's what I was looking for. But yeah, so they're creating a new key here in run. Or a new value, and then setting it to the data to it to their healthy.exe, which they've dumped into app data. And then they've run healthy.exe straight away. So the next question is, what happens next? What is in healthy.exe? For that, we're going to have to unzip this thing. I'm going to pull this off of this ISO and just drop it in downloads. And again, we're going to start here with a little bit of static before we fire it off. All right, we're going to extract the app.zip. Okay. And so we get this folder called healthy. And let's make those icons visible for y'all. Things that we have. We have this healthy.exe with a really nice icon, actually. Right? We have locales. We have node.dll. We have some .pack files. We have some more DLLs. And check out the sizes on this as well. This thing is like 120 megabytes. This thing is massive. As is the nw.dll, whatever that is. Now, at this point, I would fire up PowerShell here. Or Commander, I guess. A normal exe is about that size. It really depends. It's chunky for certain kinds of malware. And as we'll see, there are some pretty crazy things that are going on with it. Okay. So we're going to cd... I want PowerShell. Does... Actually, hold on. Does... That's really annoying. Flare should ship with the Windows terminal now. I don't know why it doesn't. Okay, we're going to cd downloads. And healthy. Okay. Do I have strings.exe on the path? Yes, excellent. Okay, so just making sure the flare is working the way that we would expect. So we're going to do strings.exe and 8 healthy.exe. Just basic stuff here. Okay? There's a ton of crap. It's actually taking so long that I might not do it this way. Hey, Dust on Keyboard. Instead, what I might do is fire up some flare tools. Yes, indeed. So good best practice first is maybe to use something like PE Studio. God, I don't know why, but something about the flare, like the flare organization, just doesn't click with me. Okay, we do have .peek and dnspy. That's good news. Like, I'll try to search for something through Windows Search, which is the way that, you know, we usually do it, and it doesn't work. What am I looking for? I'm looking for PE Studio. No items match your search. How is that possible? All right. Forget it. I tried really hard to get everything installed that we were going to need. But of course, Flare doesn't come with PE Studio. I have to tell you, I was trying to do this in a way that Husky was going to appreciate. But I have to say, like, I kind of don't like Flare. It has a lot of cool stuff in it. Is it in Disassemblers? No. Cutter is, though, which we'll get to. Looks like the PE category didn't install. Yeah, you're right. It's weird. Okay, we'll download PE Studio. Hey, can you guys hear the, or can you all, sorry, can you hear the construction outside? If so, I'm gonna go see if I can do something about that. Good. The noise cancellation on this microphone is unbelievable. I love it. All right, PE Studio, here we go. We'll probably need Process Hacker. It sounded like a threat. Oh, healthy is where we want to go. Healthy.exe, what you got for me? So I'm going to look for some strings here. Now, I did run, I should say, while this is doing its thing, I did run strings, of course, against healthy.exe here. So, and this is kind of what it sees. Now, notice that some of the runs, look at the command line options that healthy.exe picked up. What does this look like to you? What do these look like to you? Subtype storage.mojam.storage service, field trial handle, service sandbox, no sandbox. What does this look like to you? Yeah, that's right. It looks like Chrome to me. It looks like a Chromium-based browser. Yep. It's almost as though they're running with their own like their own browser. Or, and this is kind of where I was going, because we know that there is a... Yeah, that's still loading. Because we know that there is a node.dll in that thing, I'm wondering if it's an Electron app, which would be wild. I gave this thing plenty of beef. This thing has 6 processors and 16 gigs of RAM. It should be 6 cores, I should say. So, should not be hanging. What tool pulled the command line args? So you were just looking at an online sandbox called Hatching Triage that picked it up during a dynamic run. We are going to do our own dynamic run as well. But for me, it's always like a good practice to toss this thing at it, just because it's really good at what it does most of the time. Okay. So, all right. P Studio, you got anything for me? Still loading strings, so fine. Now, this doesn't look to me like a .NET assembly. So we can try to crack it open with Cutter as well and see what that does for us. It's huge. What makes huge executables? Go, Rust. But actually, here's the thing, Killer. What are you talking about? Why am I using Windows Light? I'm choosing dark theme here, and this is a flare. This is for malware analysis. That's what this this thing does. Basically, you set up a Windows VM and you use Mandiant's Flare install script to install kind of all the stuff that you need to do Windows malware analysis. And so it's not the kind of thing that you spend a lot of time configuring the appearance on, although it appears to be in dark mode here. All right, let's crack this open. This might take a minute. So in terms of things that make huge executables, so Go actually doesn't make huge executables. I think there's some misconceptions about what makes huge executables. Like, I think a lot of people think Go and Rust make huge exes. They actually don't. They only do when you have the debug symbols inside of them, and that's never going to be the case for this malware. So, like, to give you an example, Offensive Notion's debug build on Windows is like 170 megs, I think. But actually, maybe it is closer to like 117. But if I do the optimizations and strip the symbols, it cuts down to like 7. So it's not, and Go does even better on that regard, because the thing with Rust is that by default, Rust is statically linked for everything except libc. That is not true in Go, so you don't even have to include all of the static linking in your binary, so it doesn't have to be giant. What makes it giant is, you know, other stuff that's probably embedded in it, right? Who knows what this thing is dropping? Or I should mention this as well, padding. A lot of times, these things are made gigantic in order to evade antivirus and EDR, because there is a maximum size that these tools have for analysis, and if you are bigger than that, it's just gonna like give up. There are limits for those analysis. Like Defender is a good example. So Defender has inside of it a really cool thing that only Defender can do, basically. It has an emulated kernel and Windows API, and what it will do is it'll sandbox execute any executable sample that gets downloaded to it. And with that, what ends up happening is it has a time limit. So if it takes too much time to analyze the thing, I'll just be like, okay, fine, right on through. So you can bypass that a couple of ways. You can use sleep, although sleep has its own signature now, right, to extend the execution of the program. You can just like obfuscate what you're doing in certain ways. And of course, you can also have sandbox detection, where if you detect that you're only running with one CPU core or whatever else, shut down, because that's not like a realistic environment. Hate handles. Welcome, raiders. Good to see you. Thank you as always for the raid, my friend. How was your stream? All right, Cutter is cooking as well. And it's just now it's not responding. Ah, good. So, oh, your PE Studio was in utilities? Let's see if mine was. Nope. But Process Hacker is, which is good news. Yes, this is Flare. I mean, it's fine. Okay. This is taking forever. To the point where, like, why bother? And this is, okay, so this is gonna be like a very me thing. This doesn't have like the Husky Hacks actual malware analyst imprimatur on it, okay? But would you like to know what my favorite malware analysis distribution is? It's Kali. Most of the same stuff that I'm going to need for offensive work is going to be the stuff that I need for defensive work. No, not Remnux. It's too, like, Remnux is cool. It has, like, OLE utils and all that cool stuff. Remnux is awesome for, like, proper defer. It really is. And if I spent more time with Remnux, I would get much better at it. But the truth is, the best malware analysis platform is the one that you're most comfortable on, and that has all the tools that you know that you're going to want to need. And that's why I'm also going to fire up a new remote desktop connection to our Kali machine in the lab. And drop this thing on there. If I can log in. Oh, did I make it SecLab? Maybe I did. Okay, good. So, do you have any concerns exposing your NAT IP to the malware? Nope, not really. Frackery. What is ISO? An ISO is a disk image. Think of it as a virtual CD-ROM or DVD-ROM. And, Sin, the reason I don't have a lot of concern for that is because I keep a really sharp eye on what my external IP is doing in terms of if any UPnP or my router does anything wacky. So, like, sure, they can know the IP. Yeah, so there's malware in an ISO, and the reason that it's in an ISO is, first of all, this is a whole new, it's not new, but it's a more prevalent attack chain that attackers are moving to instead of using VBA macros, because those are going away. And also, people just know about them now, and defenses are in place. But ISOs are brand new, and based on what I saw this week, users are more than happy to download them. Okay, so CD documents. That's indicator malware indicator healthy. Okay, our Thunar here, and I think I can do this. This will be interesting. Can I go? Let me unfull screen this. Can I go from this RDP session to Kali? Ha 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 ha! Awesome. RDP is pretty wild in terms of how resilient and accommodating it is. The stuff that you can do with it rather than, like, VNC. I think we take it for granted, but it's pretty amazing as a protocol. Your file is ready to download .iso. All right, so we're gonna mount this up, and then yeah, here's all this evil stuff. I'm just gonna pull that out, and then we'll extract the app.zip here. Saturday Jerry, thank you for the follow. And Flokin Babasi also. Have I ever done a reverse shell that was just reverse VNC? No, I haven't. That sounds interesting. Although I would also say that one of the reasons I wouldn't do that is because VNC sticks out like a sore thumb in my environment. Okay, so let me fire up code here. And take a look at some stuff there. Oh yeah, so there's another cool thing. I learned this trick this week. Does anyone know a really fast way to analyze LNK files? I learned this one and I thought it was pretty cool. It turns out that EXIF tool, which apparently isn't installed, is that? Yeah, EXIF tool can do it. Although I have to, is EXIF tool a pip thing? You know what? I'll do that over here. It's a Perl thing. Yeah. Nice. Yeah, EXIF tool can actually read LNKs. Now, it's not perfect, but it actually does a killer job. See how long it takes to do this. That's so much stuff. None tools. No way. I'm not installing all of that crap right now. Okay. Hold on. Is it just this? It's written in Perl. Insanely. Okay, so if we do exif tool, thank God. Okay, exif tool install.lnk. Watch this. What? I had no idea. Pretty rad though, right? There's stuff that you can hide inside of LNKs that this won't show, but for a first pass, I mean, love it, right? And the icon file name is shell32.dll, and then there's resources.bat right there, which we saw, of course, right? Same stuff. Now, let's go into the healthy here. And we'll do a little strings action on healthy.exe here. Much faster. Now, obviously, that's a whole lot of stuff. Obviously, there's node modules, all sorts of good stuff going on there. Now, if I'm a... We'll see this in the dynamic portion, but just to give you a quick hit, little crypto going on here. Some JavaScript, in fact. That's going to be interesting. We can extract JavaScript from this thing. Oh, hell yeah. There's your there's some obfuscated JavaScript crypto to do something interesting. But in addition, let's do healthy.exe. Let's grep for HTTPS. Okay. Obviously, there's a lot of that going on. A lot of GitHub. So we'll do grep HTTPS, and then we'll grep -v for GitHub to get rid of the GitHub results. Okay. There's Travis, Yarn. Okay, mostly garbage here. Okay. So without more information, like you can parse through this, but without more information, it would be kind of a slog. Let's see if we can head back over to PE Studio. Still taking its sweet time. And Cutter's dead. Are we just gonna live in Alright, let's put Cutter on here and run it off this machine. I love the fact that Linux is saving us. That feels good to me, personally. Alright, so Cutter. Cutter.re. Let's just grab that app image. Put that in scripts. And so we'll chmod plus x scripts cutter app image, and then alias cutter equals. Yeah, they did. It's giant. Although some of this is, I have to tell you, Conundrum, this is about par for the course when I've used Flare in the past. It has been unbelievably slow. Slower even than just like regular Windows. I don't know what is going on under the hood there, but I don't like it very much. I think is the decision that I've come to, is that if I'm going to do Windows-based malware analysis, I'm going to just like install my own tools, because the Flare VM seems to cause more trouble than it actually helps. Okay. Yes, I know it's in light mode. We'll fix it in a second. This will take a while, presumably. Although, I bet it'll be faster than it was on Windows. We see progress. I have successfully opened up this thing. And not on, like, crypto mining level equipment. Okay, everybody happy now? So, all right, it's a PE32, written in C. That's interesting, written in C, not even C++. Entry 0 shows us a call to this guy right here. LP system time. Sorry, I know that I should be doing this in 14, what is it? 1412 94 0294. Oh, no. It was like way too far down. Or I want to do show in decompiler. There it is. And I want the decompiler weirdly not showing me the Ghidra decompiler, which is unfortunate. Why is that happening? That should just be there. Yeah, it is there. Don't know why that's not loading. It's too big for it? Whatever. I prefer the disassembly anyway. And strings. Very, very many strings. Or none. Imports. Nothing too wild here. This nwelf.dll is interesting. Get install details payload, huh? I think that the that nwdll is probably something that we're going to take a look at as well. Yeah. Signal Chrome Elf, yeah. I think at this point, we need a little bit of dynamic information. So to do that, first thing we're going to do is 10.1.99.108. We're going to set up some rules in the firewall for 10.1.99.108. And we're going to do that on the firewall. So basically what we're going to do is we're going to set this thing up to be able to speak to only a couple of things. So firewall, we're going to go to rules, and we're going to isolation. Now, right now, pretty much, we're allowing out from isolation. Allow from infra. But I think we need to knock off lateral movement. So if I do an IPA here, see, I've got 10.1.99.100, right? And so what I want to prevent, that's wrong. I want to prevent this thing from happening. Okay? I don't want this device to be able to itself reach out to other entities on the Isolation Lab network. So to do that, I'm going to create a new rule. How do I want to do this? Oh, yeah. We're going to create a new rule to block interface isolation direction out. And the source is going to be... I have to add it as a single host. Here we go. Single host is going to be 10.1.99.108/32. And the destination is going to be the isolation net. Okay? I'm going to save that up. We'll apply that change. And now, damn it. First match basis by default. To change it to direction in. Nope, that's annoying. First match basis by default. The action of the first roll to match back. So we are blocking. Everything is not explicitly passed is blocked by default. We're going to move these to the end, I think. Because this is up first. That's really annoying. All right. We're just going to keep an eye on it. Like, if I have to blow this stuff away, I'm not too worried. But I don't think we're going to be in that situation. So... here's our malware. Now, I should mention... so we just mounted this thing. And notice that all it sees is this install. This is like a default Windows installation, right? If I change that up, all this other stuff was hidden. All it saw before was the LNK. So that's how like a regular user would have experienced that. Everything else was hidden. So we're going to do this. And let's keep in mind that I'm also watching this on Elastic. So if we look at this, I'm watching sysmon logs. We don't just have to look at sysmon logs, but it's pretty good. And... okay. All right, pretty good. Nothing about the mounting, unfortunately. I don't think we have Windows events for that. Let's go ahead and perform some more of the activity. Let's run this just like a user would. All right, here we go. And yes, I have snapshotted this thing to pre-malware. Okay, so install has happened. Let's go to full screen. If we take a look at app data, Healthy has been installed. And if we look at the task manager, we should see it running. There are no running apps. Interesting. There it is. Healthy application, copyright. All rights reserved. Seems legit. All right, now let's see what we got. Lots of activity now. Now this is endpoint security data that's coming in. Is this creating alerts for us? Ooh, it is. High potential, thank you for the follow. And Sin, I don't know if I said so, but thank you so much for the resub. Endpoints. I want to focus, though, on Sysmon stuff. So we're going to add... Let's just look for process starts. We have some. Okay. Here we go. We plainly have a start of healthy.exe. Okay. And next we're going to get that process ID. And we're going to filter for that value. And we're going to get rid of the search for event code 1. We're going to look for everything that process ID has done. Whoa! Roxy, thank you so much for the raid. Or, High Potential, thank you for the raid. Roxy, thank you for the message. Good to see you. How was your stream? Hopefully it was good. Science. We're doing some kind of science here. We're doing research anyway. Lab work. What kind of lab work? This is a lab of sorts. Science. I'm so interested. Yeah, tell me more. How to make test tube babies? Okay. Oh, you're a planetary scientist. That's so cool. I am a long-term member of the Planetary Society. So thank you for your work. Working on better understanding asteroids. That's very cool. Do you focus on near-Earth objects? Do you focus out in the asteroid belt or intersolar transits? OSIRIS-REx. Oh, awesome! You're going with the Bennu data. That's so cool. Ah, that's so cool. Okay, well, this stream is very different. We're working on malware. So we're analyzing a sample of malware that I caught this week, and we're looking at what it does behaviorally. Yes. I am a cybersecurity researcher, and but before that I was a teacher. So what I try to do on this stream is educate about this field, how it works. So on Saturdays we do defensive work, blue team stuff. We call it the blue team when we're protecting environments. The red team is more offensive security, right? Using the same tactics and techniques as our adversaries to harden our environment by testing our defenses. And so we do that on Tuesdays. And on Wednesdays, we do programming. So we do all sorts of programming stuff, Python, Rust, data science, actually, every once in a while. Actually, I have a bunch of Jupyter stuff planned. And if you want to learn more about this community, you can go check out the hack list, where all of the InfoSec, information security streamers, are listed. Big thanks to GoPro Slowyo, our friend. Absolutely. Cybersecurity is very important, although honestly, planetary science also fairly important. As as our planet becomes less and less habitable, and we have to figure out, you know, exactly in what ways we're about to become Venus, or exactly in what ways Mars is not a reasonable place for human habitation. My hot take, which is going to annoy some Tesla people, is that Mars is a bad idea, at least in the super, super short term. That if we wanted to realistically consider extraterrestrial habitation, we should be focusing more on thinking about how to build larger structures at L2 or L3. I worked on the human mission to Mars, mostly tried to visit where they had. No, not until we have answers for a bunch of stuff like radiation shielding. Much better answers for atmospheric stability, much better answers for agriculture, and atmospheric filtration too. I mean, we know that the dust on the moon is incredibly toxic. One can only imagine that the highly metallic dust on Mars is going to be similar. Thoughts on Kerbal Space Program 2? So I haven't had a chance to play it yet, but I put in hundreds of hours on Kerbal Space Program. That was one of those games where it's like, oh no, this is going to become my life. Oh, your focus is on planetary asteroid dust? That's so cool. Oh, that's so cool. So a Kerbal Space Program, I think, taught orbital mechanics to more people than Embry-Riddle ever did. Like, the number of people who knew the term apoapsis, like, just giant spike. I don't think, anybody knew that term, and then you started playing Kerbal Space Program, and all of a sudden, who needs three-body equations or STK when you have Kerbal? Oh, that said, one of the best follows on Twitter for me personally is the random three-body problem bot. If you're not following this, you gotta go do it. This is like such a great way to end the day. They even put music to it too. No, it's too good. I love these ones too, because it's like, what's gonna happen? Does it ever return? Okay. Sorry. This is actually very perfect. My students used to know that if you wanted to derail Mr. Taggart, you could, if you asked a space question, that was it. That was the end of class. Like, pretty reliably. Okay. So let's see. What do we have? From Sysmon, we have the following activities. And we're in descending time here. So we see event code 5. So that's a process terminated. Okay. What process terminated? Healthy.exe. So it died, and it presumably came back. What's the next one? Okay, so here's... Right, the process got started. And then here's all those same command line arguments that we saw before. Still in the same process ID. Let's go take a look at the next thing. This looks like an image load of ffmpeg.dll, if it is in fact ffmpeg.dll. Yep, it's a DLL load event. Oh, by the way, I should mention that we can... Yeah, the parameters after healthy.exe that you saw, let's go back to that last document, because they're wild, right? We saw that in the dynamic analysis from hatching triage. And what we're seeing here is stuff that looks very much to me like a browser or an Electron app, right? These look like Chromium-based browser command line args. This one's jumping out at me though. The NW app path and this local temp NW 1982 whatever. Something there is interesting, I think. So if we look at our app data, local, and temp, you'll see we have this NW folder. And there's some stuff here, right? We've got start.bin, so we actually have some more stuff to analyze here. And I actually want to grab this and get it onto the, at least onto the Flare machine. Actually, you know what? I'm just going to put it on the Kali machine. Okay, that didn't work. I think maybe I got to zip it first. Micah, thank you so much for the follow. So just so much good data here. If we're looking in this NW folder, by the way, there's the Electron app, right? Plain as day. So we were correct in that assumption. There's package.json. So it was like dumping this Electron application. I don't know what on earth it's doing though. Except that the NW app path is here. And node modules, which is so fascinating. Like it's using JavaScript here. And so I'm going to be at home with this. So let's grab this thing and see what it's doing. I want to put it on the Kali box if I can. No? Can I get it here? It's not Java, it's JavaScript. Different thing. Let me unfull screen this. Let's see what we can do. Dang it. Oh, wait, did that work? No. I just dragged it to the desktop, didn't I? Yes. Can I put it on the other Flare machine? No. And this thing is still taking its sweet time. Yeah, this thing's too big to really process with a lot of this stuff. I'm gonna close Flare down, actually, for right now, because it's not doing us any good. There's an OAP I barely learned. BBC Basic. Did you do it on... Oh, man, what was that cool BBC terminal? The BBC Micro. Right? Yeah! Okay, I saw that in the most embarrassing place. I learned about that at the Oxford Museum of Science and Technology. They had like a computing exhibit when I was there. And by the way, if you're in the UK, if you're in England and you don't go to Oxford, you're missing a trick. It's a really cool town. Obviously, the university is amazing, but if you're in the town, it's like, it's kind of cool to be like, this place has been operating for 1,000 years. Don't apologize, Professor Toker. It's all good. It's all good. Yeah, so Java and JavaScript, even though they're named similarly, and they're literally named similarly for marketing purposes, that was why, are two different languages. Java was, you know, Oracle's, or Sun's, then Oracle's, you know, cross-platform language. JavaScript is the language of the web. That's the code that really runs and does everything in your web browser. But also in some other applications that use web technologies. Yeah, JavaScript was made pretty quickly. I don't know if it was a few days, but it was fast. Not quite. So HTML... Why is Windows Security yelling at me? I didn't want a Defender scan. HTML hosts the document. Yeah, so we'll do a quick explainer on this quickly. So the holy trinity of web technologies is HTML, JavaScript, and CSS. So if you'll forgive, I can't use my website to do it. Oh, I can use WTF bins. No to this track. Much better. Okay, so this is a site that I made. It's called WTF bins. And it is meant to track binaries on systems that make analysts go WTF. They're legit benign applications, but their behavior looks malicious. That's what WTF bins is. But so this is a web application. And so if we look at its contents, take a look at this. So let's look at the source of this page. And this is HTML, as you can see here. This is HTML, but notice that it basically has nothing inside of it, right? Definitely not these cards that you see here. None of that is present. And the reason it's not present is because what's actually happening is the browser is rendering the contents here based on what it finds in these associated JavaScript files. And the JavaScript files are going to look way different. Now they're minified, so they kind of look like trash right now. But if we actually look at the GitHub for it, you can see what it's actually doing. We can see the actual source. So for example, we go to components and the WTF bin item. You'll see that this does look like some HTML. That's because we're mixing our syntaxes here. Up here is our JavaScript. Okay. And if we look at our router, we'll see even more of it. Right? You can see that creating a router for different routes, different IDs, the about page, the contribute page. And this is the code that makes the application work. The HTML presents the JavaScript executes, and then produces content in our case. And then lastly, the last component of the Holy Trinity is CSS. And CSS is the style sheet that gives us all of the styling. This is what determines what things look like. So HTML is the document that your browser loads. The JavaScript is the accompanying code that manages behavior and sometimes can render content in more modern applications. And then CSS is the styling. Those are the three languages of the web. All right, I'm still trying to get this thing off the dang... Oh, you know what? There's another way to do it. This is why, or this is one of the reasons why, I insist on getting SSH everywhere. Did you pull this sample from the environment? Yes, I did. Let me go to downloads. So we're going to use SCP to get that thing off. SCP seclab at 10.1.99.108. Downloads. Desktop, actually. Desktop/nw.zip. I'm going to put it right here. Hell yeah. Thank you, SSH, for solving every problem that I have. Dolphin, what are you doing? That was special. There we go. So we have the nw.zip, which I would then like very much to put on the Kali box. Phenomenal. For further analysis. Also, while we're doing this, let's go back to our sock here and see if any other interesting activity has taken place. Doesn't look like it, but that's because we're filtering on the PID here. I think we may have to do... Add a filter. Add a data stream. Dataset filter is... Oh, is it not dataset? I thought it was. If we look for code 1 or event.code1, we'll get back to all process starts. Now, oh, yeah, I wasn't crazy. Data stream, data set, Windows Sysmon operational. So we're going to filter for that value to just look at Sysmon logs. Right? Everything that's going on that Sysmon sees. Okay. And notice that we have there's still a lot of junk on our table here. I want to make this a little bit cleaner to review. To make that happen, I'm going to toggle this column in the table, the event code, which we know is good. We know that we want the image as well. We want the process ID. Oops. Let's go to this page. Log level. Right, so the process.executable, if it's there, toggle the column in the table. And then what else you got? winlog.process.id. We'll add that as well. Okay. We have some cmd.exe going on here, which is really interesting. I want to see, can I get the command line args? Process.args. We definitely want that in the table as well. And look, we can see, oh, that was me doing nw.zip. That was me. Nevertheless, something that you want to see happen. So what we're looking at is SSH. That's stuff that we would expect. Yeah, so event 2s from healthy.exe. These are interesting. File creation time changes are actually kind of rare, and they may indicate time stomping. So that's pretty interesting to see here. I'm just going to look at the whole message. What file are they changing? Yeah, this temp file. So they're time stomping the creation was 730, 1810, and then previous creation time. So they're backdating it. So that's really interesting. Presumably what they'll see with the temp files is if they're backdating it, if you're looking for new files that have been recently changed, you'd be missing that. That's why you do time stomping in the first place. That is interesting. By the way, those of you who may be interested in the eLearn Security Certified Threat Hunting Professional certification, time stomping is one that's easy to miss. Be on the lookout for that one. Okay. Did you learn time stomping? Yeah, it's and it's not just a Windows thing. Time stomping happens on Linux as well. Can possibly trick recovery software. It depends. So we know this thing is launching, and it's using that NW app, which we now have in our Kali box. And I really want to crack into this thing. What is malware against what is a hack, and why should we be concerned? So one thing I'll say is that the term hacker has been abused. Hackers are good people that make new things. criminals and attackers are the ones who do crimes and attacks. That being said, malware is malicious software. Hacks or attacks would be attempts to use vulnerabilities in software, to exploiting those flaws and gaining entry into systems that people are not supposed to have, and potentially installing malware to do what they want to do. So, for example, if you have and sometimes it's not a technical vulnerability that's getting exploited. Okay, sometimes it is a human vulnerability, and that's what phishing is all about, right? Which is far and away the most common attack vector for attackers. It's not a new term for Trojans and viruses. I don't want you guys to be mixing up these terms. They are all distinct things. Okay? Trojans and viruses are both flavors of malware. Malware is the container term for both of those, and they do different things. And there is also malware that is neither one of those. All right, let's take a look what we have in here. So, entrance app.html, what you got for me? Nothing. Yes, malware is a better umbrella term. Said innovations. What do you got for me here? Some CSS. Now we're looking at web stuff. This is what I want to see. What are we trying to do here? Some JavaScript. This is all JavaScript. There's no iframe template. It's about dot blank. And then search button. That's all CSS. I don't worry about that. Where are the links going to? At the moment, they're not going anywhere. These are buttons that, again, this is where JavaScript really comes in. This is a newer kind of web application where everything you see here is going to be controlled by JavaScript. Now, it looks as though load and fade out slow. Loader dot fade out slow. So it fades out the loader, but then what does it contain? We have an iframe here. New fake top, NW fake top source equals about blank, so it's not really doing anything. Let's take a look at the open.html. Aha! There was that crypto.js that we saw. So this is all dumped. That was all in plain text in the healthy.exe to get extracted and dumped into this application here. Yeah, this is a lot. Okay, so we have a start.bin. And look at this. We have some data and an IOC. We have scotsman.com. How do you read this? Practice. I'm not reading every part of it. What I'm seeing here is that this is plainly a decryption routine to get at this junk. No true Scotsman. Scotsman.com. Notice that it's posting data, and what it's posting is this base64 encoded, or this information right here. Which is what? Okay, so we have like probably an identifier for the beacon. Okay, and then start.bin. What is start.bin? because we see nwwindow.get. Eval nwbin start.bin. We have it, I believe. You know what? We can close cutter. It's not really doing us any good right now. Okay. Okay. What is start.bin? Let's just run a file on it and see what we find. So it's just data. I bet you anything this is the Cobalt Strike beacon or whatever it is. What is the what did I use for a decompiler? So the disassembler I was using was called Cutter, and then inside of it it has the Ghidra decompiler, but honestly, I'm at like a weird point in my life where I tend to look at the assembly more than I do the decompiled code. That's just because I'm a broken human that has looked at too much assembly at this point. My SecOps Rocks mug. So start.bin data, let's run strings on it. I bet we won't find anything, but we'll do it anyway. Oh, all right. All sorts of stuff in here. Possibly passwords. Anon hacker. Process args, settings, child process, local storage. Kicking stuff off. Part of maybe a JSON web token. Yep. And again, scotsman.com. So if you want an IOC, an atomic, there's your IOC for this one. By the way, the other thing I want to do, this thing should be making network connections, right? So I want to do code event code.3. I want to see all event code 3s. Nothing at all. Okay. No network connections to speak of. Is scotsman.com up? Oh, right. The other thing I need to... This was so cool to discover. I don't know why I had never played with HTTP pies before, but way better than curl for most things. Watch this. If I do HTTPS scotsman.com/RSS, that'll just run. Now, it looks like I'm not getting anything. The Diffie-Hellman key is too small while doing GET request. Can I make it ignore? Or let's do HTTP post, because this looks like it's got to be a post request because we're sending data. Any difference? Nope. That's interesting. This is what it's supposed to look like. If we do HTTPS and like against my website, check this out. Colorized output. Get you off track with wrestling with this myself. How are you planning on tackling those DLLs, figuring out what they do? So the DLLs, so Technique, that's a really good question. And I want to answer it in like a pretty good, like a detailed way. And here's how we're going to do that. We're gonna go into healthy, which is where those DLLs were. And we're gonna look at first healthy.exe. So I'm gonna do xxd healthy.exe to less. This is gonna be like rough. Okay. Actually, that worked out much better than I thought. Take a look at what we have at the first byte in the healthy.exe. See how it has this MZ file signature? Okay, this marks it as a Windows portable executable. And of course, we have this junk here. The program cannot be run in DOS mode, something you usually see in this. Yeah? Okay. Now, let's do the same thing with the nwelf.dll. Look at that. It's the same thing. So you can use disassemblers like Cutter to analyze the DLLs as well. And in fact, if you're using something like Ghidra, you can connect the DLLs to your executable into a whole project, and it will link them for you. That's actually one of the things that Ghidra it does very well and does better than Cutter, I would say, is connecting you to DLLs, especially on Windows, connecting you to the Windows API, things like that. So if you wanted to do a full workup, you can do that by connecting those DLLs in that way. But if you want to do one-offs, like let's look at, we can do the nwelf.dll. Right? We can read it with Cutter. Which makes sense if you think about it, because we saw that in healthy.exe there were references to this DLL. Now, one of the things that is a huge pain when you're doing this for real malware is that all the debug symbols are stripped, so it's not going to look like your CTFs. It's not going to look like pwn.college, right? None of this stuff is going to have function names on it. The graph view is really helpful to see how things proceed. And I like going from the imports as well. Right? Oh, hey, create remote thread. That's interesting. I want to show the cross references to create remote thread. Where does that happen? Oh, okay. Well, that happens there. Take me to that. We'll show that in the disassembly. Inject, dump for, we have actual named functions. Look at this. Set, upload, consent, export thunk, inject, dump for hung, import, export. Dump hung process. I didn't expect to see any named functions in here. Oh, but we do have some. These are flirt. That makes sense. I think this has to do with the libraries that they're using more than anything. No, they have some symbols. Disable hook. Well, thank you. Thank you very much. Yeah. They didn't strip their DLL. Thank you. Thank you very much. Look at that. Hey, there's your signal Chrome elf. What is this one doing that's bad, though? Well, we don't know all of this yet, but what we can begin to intuit is that it's reporting data, and I'm still, like, pretty confident. Now, this is a DLL, so we don't know everything this is doing, but I don't want to get off on this track too far, because the next thread that we pulled, right, let's kind of back this up. So we know that the malware installed this thing called healthy.exe. Healthy.exe launched itself with all of those command line options. One of those command line options pointed to a thing called NW-app, and that's what we pulled off of the system that we had running the malware, right? This NW-app, which it dumped out of itself, by the way. Healthy.exe contained this application inside of itself. Now, it looks for all the world like an Electron app. It just does. And so what with this start.bin, which is 12 kilobytes, it's really small, which is compelling to me that this is like shellcode, right? So, or something. And there's also this fdyd.bin, which may also be shellcode. We'll take a look at that as well. But that it's using this web technology to kind of do the hosting and for its application layer. Okay. Let's go back and analyze that then. Okay, so we know that we have this start.bin and this app.html didn't have much. I do want to check out settings.js just in case. Oh, interesting. Appupdate.herokuapp.com. Herokuapp.com. So something's getting hosted on Heroku. And this is actually, I'm glad we got here, because this is something I wanted to get to, actually, with, yeah, I'm going to close this. I wanted to get to with our other stuff. So, strings, this is something I found at work, but check this out. There are Heroku-based strings inside of healthy.exe, and they're really interesting. ddserver.herokuapp.com/report install, pg-get-app-up, and pping, or pget-up, get-app-up, pping, pappk. These appear to be startup for the application to indicate that it has, in fact, made contact. I am confused why we're not seeing those network connections from Sysmon, right? On our SOC system. I feel like we really should be seeing them. But in fact, we're seeing no event code 3s here, which is pretty odd. Now, just as a sanity check, I'm going to do a check for that on this system, and I'm just going to fire up the event viewer just because it's fast. And remember, this thing is actively infected. No need for Wireshark just yet. All right, we'll let event viewer load and head back over here. Package.json. Let's format this document. Okay. Very good. So This is simple app for your simple purposes. Very good. And the main is open.html. Okay. The window is going to have the app icon, which is in images. Okay. IT Professional, thank you for the follow. Char3176 and a non-hacker, thank you for the follows. Also, Ninja is unhinged. Yeah, and okay, so here's some Chromium arguments. Let's see what we're seeing here. Nothing wild. JS flags, expose GC. He meant for Shark Week. WebView, accessible resources, all URLs. So what are we using? Axios, this is to make network requests easy. OS utils, terrifying. System information, also terrifying. Universal analytics, weather.js, GeoIP, and Moment. Moment is a time thing. Node.js is true, private is true, single instance is true. Okay. So open.html is where this app actually fires up. So, and we saw that that was like the evil one that had the start.bin and these others. And I'm going to look at this jQuery.min.js too, just because I'll bet you anything that it isn't just jQuery. Actually, this does look just like jQuery. And if you think, wait, no, you can't possibly read this and see that it's just jQuery, sadly, I can. I've looked at jQuery enough to be reasonably able to spot stuff that isn't supposed to be there. So this looks like actual jQuery. There might be something hiding in here that I'm not seeing. We'll format the document. Oof. Sorry. Sorry, VS Code. Oh, it didn't even give me anything anyway. So one of the things that I think is really interesting about this so far is that it's not doing anything. It's not doing anything that is kind of normal for Windows exploitation. We're not seeing calls out to scheduled tasks. We're not seeing calls out to WMI. We're not seeing calls out to PowerShell. None of that stuff. And I believe that's because we haven't gotten there yet. But it's interesting that this web application, essentially this Electron application, is what's hosting all of this. Now, let's take a look at this Electron package.json, because again, Electron is a technology that allows you to basically write a web app and wrap it in this thing called Electron and ship it as a desktop application. Visual Studio Code right here is an Electron application. So is, if you use desktop Slack or Discord, also an Electron application. And so we're looking at all of the Electron stuff that is configured here. So again, we're using Axios, Moment, Universal Analytics, and the title is app title. Main is main.js, which, by the way, is where? We don't see it, right? We don't see a main.js. Okay. So we looked at we looked at start.bin, which is 12K. And then there's this fdyd.bin, which is 99K. What do you mean, like Visual Basic, Professor Toker? So far, we're not seeing... There's no Visual Basic in this either, which would be another Windows behavior. The most Windowsy thing that we saw that this thing has done is fire off that resources.bat for the initial installation, the batch script here. After that, it's all been this very bizarre kind of chain of installations. Okay. Hey, check this out. We've got another indicator for ddserver.herokuapp.com. A user agent. Okay. This. We've got some more domains. Yeah. HTML. The Electron package. Did the Electron app ever open? Yes, it did. So here's how we know the Electron app opened. It's not, and this is the thing that's wild about it. So I think that's why they're doing this. It is kind of like a Chrome extension. Let's learn a little bit about what that NW app is all about. So nw.js is this library. And what is it? Node WebKit. So check this out. Lets you call all Node.js modules directly from the DOM and enables a new way of writing applications with web technology. I want you to marinate on that for a second. All Node.js modules directly from the DOM. Well, guess what? One of the Node.js modules is going to be child process. Right? Node, which is an engine for running JavaScript on a server outside of the web browser, has inside of it a library called child process, which allows you to kick off commands on the endpoint. And it also has a file system library that allows you to read stuff from the file system. And this is stuff that is not supposed to be accessible to Electron. But because they're using this Node WebKit library, and by the way, does that icon look familiar? Because they're using Node WebKit, they're able to do this. And so what we have seen so far matches that exactly. Let's go back to Elastic and just take a look. Say process.executable. Let's filter for this value. So take a look at our command line arguments. Can I resize these? Excellent. I was like, these don't need to be that big. They're process IDs. Is Node installed on your computer? Were they able to install that too? Node didn't have to be because they loaded it themselves. That was one of the DLLs that we saw, was node.dll. So they're literally just packaging it with it, and that's not too surprising. In fact, we've even seen legitimate applications do that. If you remember, a couple months ago, I did some research on the Adobe Creative Cloud experience, right? Which turns out packages its own version of node.exe inside of it, which allows you to do this exact kind of thing if you wanted to use it. Let me see if I can find that right up. Yeah. Here's the thing in the register about that. And I did a thread on it as well. By the way, not the only thing. NVIDIA, the NVIDIA experience or whatever, also has a packaged version of node.exe. And that one's even more wild because that one runs as system rather than as anything else. But okay, so in terms of did we see the Electron app actually run, the answer is yes, kind of. And here's how we saw it. Here's healthy.exe. Let's see a more recent one. Yeah, I think any of these will do. Let's expand this. Yes, right here. Okay, I know that's a little bit small, but see this NW app path for C user seclab, blah, 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 and then the app path? That's where it's getting loaded. So it's loading, it's the browser itself, but it's loading the NW app into itself. This is like an older version of Chrome extensions. I don't know if anybody would remember this, but back there used to be another kind of Chrome extension called a Chrome app. And a Chrome app, the API, by the way, for it is still in the Chromium browsers, where you can pass it like app path. But it's not an extension. It doesn't have the same structure. It basically has like a web app structure inside of it without a manifest.json. And that's what's going on here. It's just with the NW app path. And so this Node WebKit library is being used to package all this and then launch it. And then in comes this NW app. So that's where we're seeing it launch. And because it's all going to happen under healthy.exe, we're never going to see another process for it. We're only going to see events from healthy.exe because everything else is being governed by JavaScript. It's pretty slick. Now you still have to miss healthy.exe, but not impossible, right? Okay, so I'm seeing some JavaScript stuff here. Call setup again, original version, remote settings, read file. I don't know that this is Cobalt Strike. There is a way. Ah, good. This is why I star everything. Yep, there is such a thing as the Cobalt Strike parser that allows us to parse the config. So it parses for stageless beacons, memory dump, or CPU mass fluid. So many stageless beacons repeat using the beacon code itself is stored in the .data section, XORed with 4-byte key. So we're gonna try this. I'm not certain that it's gonna work, but it's worth a shot, I think. So we'll send this over to scripts. We'll git clone that Cobalt Strike parser. Okay. And then we'll, from here, we'll Python 3 scripts, Cobalt Strike parser. We've got beacon utils. We'll do parse beacon config py, and we'll give it the fdyd.bin. Oh. Make sure we have everything we need. If this seems like a lot, that's because it is. This is quite a lot of work. And this malware analysis, this is beyond the scope of what I think inside an organization you could reasonably be expected to do. Dan Mulvey, the Blaster, thank you so much for the follows. Okay, that's not working out. Yeah, no. Python 3. Let's do start.bin. I don't know if it is a Cobalt Strike beacon. There's beacon utils as well. Zahir, also thank you for the follow. And that's honestly okay. So we're not seeing whatever this is, but we know that start.bin is used. Well, for one thing, we know that it's used in if require fs exists sync start.bin nw.window.get eval nw.bin start.bin. So we have to learn what the node webkit eval nw.bin function does to learn more about this. Oh, it's literally like eval. Oh, that's so funny. So is it... Frackery, go ahead and just ask. Frame path. Frame to execute if iframe is null in the path. So null and then, yeah, the path. So we're evaluating start.bin. Whatever. Yeah, open this anyway. Okay, so it's like a lot of garbage. Appname.wj.exe. There's plainly more going on here. So let's go back over to that endpoint and see what else we can see. App data local temp. Anything else in healthy? User data. Default. Notice that this looks like a browser, because it is. What happens if we just launch? Data. Cool. Healthy. Notice that it's changed shape. It no longer shows healthy.exe, right? It did. But now, there's roaming, healthy. Oh, no, there it is. Never mind. If I just launch this, what happens? Do I see it anywhere? No, I do not. Ah, but we created a new NW. Do you think the Microsoft security certificates are valuable for someone looking to specialize in security with a Windows environment focus? Ooh, okay. So I do, at least for the Azure stuff. Although I have to admit to a bit of a bias there because I myself am going after the AZ500 Azure security certification. And I do think that that information is super important and worth getting, and also pretty affordable to get. The value there is, the value for money is it's pretty good. So I think that's worth doing. As far as the endpoint stuff, I'm not super familiar with what Microsoft's offerings would be there, but definitely the cloud material, because they're the only ones that have it. Yeah, they're a learning platform, especially setting up the Azure Labs and doing it like directly from their platform and then tying into your subscription with the Azure Resource Manager is really cool. I really like the way they do that. Oh boy. All right. Getting to be a bit of a long stream here. Yeah, AZ900 for the Azure Fundamentals is really good. I don't know if it's worth $100 for the cert for that one, or for the exam, but going through it is definitely worth your time. And then AZ500 for the security, that's the one that I'm going for. And then AZ700 is the networking, also pretty good, especially because, boy, networking in the cloud is so strange. It's totally different. Okay, so we've kind of seen that this gets open, and then this start.bin is where everything else kind of moves to. I'm concerned still that we're not seeing those network connections with the event viewers open. So let's see if we can make this happen. I'm going to go to Applications, Microsoft, Windows. Yes, I can do this in PowerShell. No, I don't want to do it just yet. I will if I have to. Sysmon operational. Okay. Definitely there are. Look at this. We do have network connections. So this is actually what we want to do. We want to filter for event ID 3. And also, if you're looking at Windows event logs, personally, I do not like the general view. I don't even like the friendly view. I want the XML. The easiest way to see what's going on. Right? We get destination host name and all this stuff. Okay. Looks like it's all this LAX router business. So that's unhelpful. That's SSH. Yeah. I think that we will not see beyond that. I also don't know if that's right. Yeah, that's from the Goog. I think that the IP address is not actually... it's reporting this for the resolution, but I think that's the first hop. I don't think that's right. Would you like to see how to parse these logs in PowerShell? We've done it before on the stream, but I'm not sure if that's of interest. I'll do it if we want, but otherwise we'll just skip past it and see if there's anything else interesting to see here. eval NW bin. Eval NW bin. What is an NW bin? I guess is the question. Yeah, I don't think we're going to learn anything from doing it. We'll do like a PowerShell defer at some point again. But basically what you want to do is, this is kind of the, if I was going to tell you something, this is the point I was going to make. PowerShell logs or sysmon logs and actually all Windows event logs are kind of a huge pain because most of their useful data is in XML. However, I think it's win event log. Yes. This extra PowerShell package from the PowerShell gallery gives you the ability to extract the Windows event log message into a parsable PowerShell object. So you actually get the data that you can work with programmatically in PowerShell. And so that gives you access to all of the components without having to do like XML parsing. That is, this really like unlocked for me easier ways of dealing with Windows event logs in PowerShell, because I then get access to all that rather than having to like do find string or whatever. It hasn't been updated in some time, but you know, neither has the spec for Windows event logs, so I think you're fine. Okay, so this eval NW bin, protect JavaScript source code. Okay, so this is the deal. JavaScript source code is compiled to native code with the tool nwjc, which is provided in the SDK build. The .bin file is needed to be distributed with your application. You can name whatever. Okay, so that's what we're looking at here. We're looking at these .bins. If you're compiling a module, NW module argument is needed. Interesting. Interesting. Okay, so that is where everything is happening. Can we reverse NWJCs? Yeah, let's go. Not helpful. I doubt it very much. So we're gonna have to just kind of take a look at this thing. We've done strings. Let's take a look at this again. It's small enough. Let's look at Vim here. Now, this is ugly. What we're going to do is we're going to turn this into a hex editor with XXD. Okay. And we're going to try to see what's going on here. Local storage. So it's using local storage. There's some decryption going on. So this itself may be a payload here. Set timeout. I think we're looking at a key here. I think we're looking at a decryption key. And that one is even more... I really do. I think we're looking at a decryption key here. Now, it's honestly beyond my abilities to start decrypting this stuff. I mean, it looks like it's AES, but to find where the bytes are of the beginning and the end of the payload... Get proxy for URL. It's testing to see if there are proxies. I think there were some numbers on that too, Yanner. Request key from server. Okay. Now it's using Grunt, which is interesting. Grunt is like a job runner. It's an old school job runner for web applications. Google Analytics. Okay, here's our ddserver.com/Heroku app or ddserver.herokuapp.com/report install. I'm gonna just make that request. And actually, I'm gonna do this with curl. Okay, we got a 404 node, not surprising. Cannot get report install. All right. Let's run it as post. Which would make sense if they're sending data. Ah, we got a 200. Now it said failed. Possibly because we didn't have the right payload inside of it. Just give it some garbage. Okay, so it says failed again. I'm not hacking back. I'm just seeing what the endpoint does. Opened shell thank you page, huh? Cowboy server. Yeah. Now that's Heroku. That's nothing the attackers had control over. TMZ.com. App name. Okay. Actually, I want to run strings again on this thing, and I want to look for some other stuff, like user agent. Maybe healthy. User agent request, huh? Let's grep for Heroku again on this thing. Because there were other endpoints, right? And does this also contain Scotsman? It does. Just scotsman.com/RSS. So we know that the get didn't work to it, right? Yeah, the SSL signature type was wrong, which is interesting. I'll give it the -K to like ignore stuff, but I don't think... Yeah, it still needs a good TLS signature, so it's interesting that that's no good. That may just be a one-way communication. Here, let's go for Heroku. So there's report install, which we tried. And let's try PG, or P, get app up. Okay, said failed again. Let's try P app K. Oh, we got data. Got some base 64 encoded data here. Probably nothing. For this one, I'm going to go to CyberChef, just in case this becomes useful. And then I think we might shift gears. Oh, right. All right, from base 64 gives us something. It says salted. All right, I'll bet you anything this is the AES key that it needs. But this is just unreadable bytes. Yeah. Okay. Was there anything else of note that we wanted to take a look at on here? Anything else fun happening? Is it doing anything at all? All right, we're not seeing anything. Let's look for like PowerShell.exe. Nothing. CMD.exe. Yeah. Because it's not. It's kind of just doing whatever it wants to do. I actually think what's going on is that it's... I have to do a little bit more diving on this, but what I think is happening, and this is so honestly cool, is that it is... Actually, let's try one more thing. Let's add another filter for the parent executable. Parent executable is... No, come on. Is the only parent executables it sees? Let's look at this healthy.exe. process.executable, process.parent.pe, or process.pi company. Process parent.pid. Let's filter for this value. Let's just explore, I think. Yeah. Okay. Well, right. So let's talk a little bit about prevention. How do we prevent this from happening? We've detections. I think that you should be looking for anything that looks like this. We're gonna do like last 3 hours. Apply. Okay. So we're gonna do something like event.code 11. Let's look at file creations. There's all this MS Core Worker. And .iso. That may not be there. But you want to look for stuff like detections that I have in there would be like looking for where a file is created with downloads slash star.iso, any .iso download. Because what we're seeing is that these attacks are getting kind of watering hold, right? Where you browse to a site and they kind of do a pop-up and you're prompted to download something. The user does. They open it. Then they follow the next logical things they would do to get at whatever they were trying to get at, whether it's like a pirated movie or whatever. That first detection should be that .iso is downloaded. Yes, there are legitimate uses of disk images in environments, but they're exceedingly rare. And so you should be looking for those file creations, especially in the downloads folder. And you can do some work on like exceptions for that. Like if they came from, Microsoft.com or something like that, that's where a lot of the ISOs come from, or from Ubuntu.com. You can do some work on that. But the primary detection of looking for downloaded ISOs is going to get you a lot, right? And then after that, you need to be watching like a hawk for what those things are going to do. We see that batch files should be running, but users are going to run those things. So how do you prevent that from happening in the first place? Here's one way. And let's talk about remediation, by the way. So now we've infected this thing. Let's de-infect it. So for de-infection, first thing, let's fire up some PowerShell here. By the way, if anybody has any other questions, please don't hesitate. Actually, you know what? I'm not going to PowerShell this way. I'm going to PowerShell the cool way. Yes, I'm going to PowerShell the cool way. I'm going to zoom that in a little bit so it's easier for you to see. Over SSH. Okay. So, fun fact, if you SSH in as an administrator, you automatically have admin privs. Look at that. I'm a high context, which means I have the admin token, which means I can do stuff. So first thing we want to do is get item. What is it? HKCU software, Microsoft, Windows, current version, run. I can't believe I got that in one. We want to remove that item. So we want to remove item property. Hold on a second. Name. My bad. Not property. Name. Now it's gone. You could do that with regedit too. I'm just trying to be cool. I'm not succeeding. Using PowerShell to edit the registry is not cool by any measurement. Okay, so we've removed that level of persistence, right? Keep in mind that thing might come back. So you want to do a final pass on that. Oh, you're going to do a phishing and malware analysis session. That's really cool technique. The calc loader one is really neat. I want to see that. And okay, so now we're going to go to cd app data. And obviously we need to go to local. Oh, also, sorry, we got to kill running processes, right? So get process. Now, get process, this is kind of interesting. We're going to do where process name like, or process name equals, because we know the process name is healthy. Quotes. Okay. We just pipe that to stop process. And now they're gone. No more healthies running. And then that's a little, do you see how that works? You get process, pipe it to where the process name equals healthy, and then just pipe that to stop process, which will iterate over the array and stop process for each one of those objects. It's pretty cool, right? PowerShell can be neat. And then we're going to remove item healthy recurse force. See you in hell. We got to go up to roaming. Actually, and then go cd temp in this case, right? All right. So we're going to remove item NW. Got to knock that off. Now it's gone. Okay. And then finally, of course, you would have to delete this ISO. But how do you prevent it from mounting in the first place? It's kind of the important part here. How do you prevent this from mounting in the first place? This is kind of cool. We've essentially cleaned the machine. All right, let's do one more pass just to confirm that the registry key is still absent. Yep, just one drive. That's what you would expect. Now, how do we prevent this thing from mounting? There is a way. Actually, there's more than one way. But there is a way to actually prevent this from mounting by GPO. If you want to prevent ISOs from mounting via GPO, there's a way to do it. Here's how. Let's go ahead and mount this thing. There's a reason I'm doing that. I'm gonna go to this PC and go to properties on this DVD drive. Here's why. We're going to go to hardware and properties and driver details. I know that we're going in a bunch of, oh, nope, not driver, not there. Details. I always do that wrong. So not here, but details here. And go to the matching device ID. See this thing here? I know it's a little small. The SCSI CD-ROM MSFT 4 underscores, it turns out. Virtual underscore DVD-ROM underscore. This is the device ID for the kind of thing that we just started. Now, I am not in a domain here, so I can just fire this thing up and have it work. I'm going to edit the group policy for just this machine, just to show you what it would look like to create a GPO to prevent this from happening. Okay. We're going to go to administrative templates, Windows components, I think. No? System. Device installation. So Windows components, system, device installation, and then device installation restrictions. And check this out. Prevent installation of devices using drivers that match these device setup classes. By the way, this is definitely like the most Windows I've ever, like the deepest Windows thing I've ever done. But this policy allows us to set up specific, so prevent installation of device drivers for these device setup classes. Right? So we're going to go to right here. Now, the reason why this is nice is because this can be this property or this policy can be disabled by administrators if necessary. But here we're going to put in SCSI CD-ROM / CD-ROM MSFT, and I believe it is case sensitive. 1, 2, 3, 4 underscores virtual. Yeah, underscore DVD dash ROM underscore. Looks good. Okay, apply. And hoping everything's good there. Okay, so that's enabled. We're going to eject this thing. And then we're going to run, I'll do this from my SSH section because I have it up. GP update. I think this is right. If anyone knows better, please. Damn it. This was the recommendation that I heard about how to make this work. Unfortunately, it kind of seems like that's not sufficient. So I have more work to do to figure out how to make this happen. There is, I know, there's like a registry key in theory. That's like a really bad idea to delete. That'll just prevent you from mounting all ISOs. And it's in HKey class's root. And I want to say it's like device. Like DVD? No. There's like an ISO registry key. Oh, HTTP classes root, is it windows.iso file? Yeah. Windows.iso file. Shell, and then mount. If you delete this, if you can. I don't know if you can. Oh. Now it doesn't mount. So that's how we do that. Right? So that is what you want to do, is you want to knock off. I don't know if he's watching, but I want to thank my coworker Mike for that recommendation. That was super savvy. Yeah, so knock this off. So ISO window computer HKey classes root Windows ISO file shell. Cullen, thank you very much for the follow. Great Irish myth there. Symbian. Appreciate it. Yeah, so that's how we do it. Computer HKey classes root, Windows ISO file shell. Write a thing that knocks that off, and your users will no longer be able to mount ISO files, which in almost every case is exactly what you want to have happen. And that's how we prevent ISO files from becoming the source of frustration in our environments. Little bit of housekeeping cleanup here. I'm just going to disconnect from this thing, and I'm going to blow it away because we don't need it anymore. Just going to power it down. And Flare, thanks for nothing. Stop both of these. And go to Flare here and just remove it. Ooh, actually, I brought Flare up with Terraform, so I'm going to do that over here. Terraform destroy. Auto approve. But I can knock off the ISO test because I just brought that one up as a straight clone. Down you go. All right. Light is green, trap is clean. And we'll clean up the malware on our Kali box, which performed like an absolute champion for our malware analysis. Thank you very much to Kali for working for both Red Team and Blue Team. And that's going to do it for today. So quick review on takeaways. We want to watch out for ISOs. We also discovered that this Node WebKit pattern, and in particular, you know, the Node WebKit moving to from a browser, basically an Electron app, and then running Node WebKit inside of it, is going to make it look like there's nothing going on inside the code, but there is going to be stuff going on inside with these binary files. Those binary files, those .bins, are in fact JavaScript that are obfuscated, but there's going to be JavaScript in there that may in fact have shell code or whatever else, because remember, it has access to the file system-based APIs for Node. So it could be launching beacons, it could be, you know, running shell commands, whatever else is going on there, but it would be a little bit difficult to see that. At any rate, so we know that that's a TCP to watch out for as well. And finally, to disable ISOs, we're going to get that HKey classes root windows.iso file shell string knocked off from the default of mount. And that is how we prevent infection in the first place from this attack vector. And that's the idea. All right, so that's going to do it for today. We have, I believe, GoPro, who is streaming right now. So the Saturday plan is working as expected. So thank you so much for hanging out, especially after the initial technical difficulties. Hope you learned something. I know that I did, and we'll be back on Tuesday doing some red team stuff. So until then, friends, be good to yourselves, be good to each other, and happy hacking. Thank you very much. See you next time.